Integral from 1 to 36 e to the 3 squared of x. You can start doing integration by parts right away. That's what I would do. But you can notice also that e is raised to a function instead of just x. So we can start with u substitution. And because integration by parts and u substitution both use variable u, it might make you feel confused. You can choose any letter you want. It doesn't have to be u substitution. I told you one of my favorite one is J. If you choose this to be J, then it's going to be DJ, which is funny. And also I like because it's the first letter of my name. But let's perform u substitution. Let's perform this substitution and just choose any other letter. Choose a letter. And I will tell you if it's a bad choice or not. Don't choose O. Did I tell you the joke about the O? So when I was a graduate student, the professor was a fancy professor, and then we were reading their articles, and they chose O. It was very unusual. It's like, why is like O, square root of O, dO, and it's like differential equations. So it's lots of stuff happening there. So I said, this is a weird choice. Why would you choose in the whole, from all the alphabet you have, why would you choose O as a letter? Well, the professor was in the classroom. I did not know that. So he was a very famous professor. So he was known in the field in mathematical biology and physiology modeling. He's like, Julia, you don't like my O notations? And I was a freshman also in the graduate school. So it was very awkward and very scary. And I like, yeah, but it's a bad choice. So since then there was like a whole story that some Ukrainian student did not like the notation of a famous professor. But I still think it's a bad choice. So don't choose O. Why would you choose out of all the letters O? It's a weird choice. You see dO? Like, can you imagine having triple integrals and you like O squared and it's like sine of O? What is happening here? That's just so weird. Why would you choose that? So I still said I did not like it, but it's fine. Choose any letter. That was like a topic of any letter. H. Yeah, H is good. Why not? You want smaller H or capital H? I guess small is better. Capital usually means some kind of name of the function. H is a good choice. Let's H be 3 squared of x. So that is substitution. Substitution. Do you know why I put 3 equal sign thing? If you put 2, that's equal. If you put 3, it's kind of defining. That's an international notation. Then DH is, do you know what is derivative of 3 squared of x? Yes? Wait, yes? 3 over 2? Root x. So 1 over root x? 1 over root x. Agree? So x to the 1/2 becomes x to the minus 1/2. 1/2 goes down. Very good. Thank you. dx. And now we also need to change limits of integration, right? So let's do that. Then I will show you everything with definite integral. When x used to be 1, then h is 3 squared of 1, which is 3. Is it a bad choice of color? Let me know if you don't like orange color. When x used to be 36, and that's why they gave you 36, because they knew that the square root shows up. Then h is 3 times square root of 36. 6 times 3, 18. So the integral becomes from 3 to 18. Agree? Yeah. Thank you. And now I'm going to write down the new integral is, usually I try to go right after the table, but I guess it's fine, doesn't matter. New integral is from 3 to 18. You substitute, a substitution is a transformation. So we're transforming e to the u, and then dx is dh. From here you can solve for dx. dx is divide by all of this part. This is still part of 5.5. We're dividing by 3/2 and 1 over square root of x. It means we're multiplying by 2/3 square root of x. So it's going to be 2/3 square root of x dh. So that's my tail. 2/3 square root of x dh. Isn't it kind of weird though that we have 2 variables now? So it's not good enough, yeah? Oh, yeah. So equation number 1, let h be 3 square root of x. Equation number 2, then we find derivative. Then step 3 is we need to solve for this part over here. So I'm solving for dx from equation number 2. That means I'm dividing by this whole thing in the blue box. Dividing by 3/2 is multiplying by 2/3 and multiplying by square root of x. Thank you for asking. Very good. So this is my tail. Do you think it's weird? Now we have x variable in the integral, yeah? Oh, thank you. Bad habit. H. dh. So I like e to the h. I like dh, but I don't like we have square root of x over there.
What if we just take root x as h?
Root x
Because
as
in the
h.
differentiation, if we get 1 over root x, then the root x will automatically become h again. So there will be only one variable.
Very good. So, but I'm just a little bit concerned what to do with 3. So you're smart because actually we could make it simpler and choose square root of x to be h. But then it's still going to be a little bit of u substitution. So let's be careful with the 3. Here's the idea for you. And that's why homework is for homework. It's going to be more complicated than test. This takes time and this takes some thinking. What should I do with this? Professor never explained me what to do if square root of x never went away anywhere. So one of the ways to do it is to go to the equation number 1 and try to figure out from there. If h is square root of x, square root of x is h by 3. So from equation number 1, I will do one more step, and I will call it equation number 4. That's an extra step. I will solve, let me do another color. I will solve for square root of x to substitute it in the tail. Oh, it's such a bad choice. Let me choose pink. Here, bless you. So it's going to be, let me put it in red, square root, let me put it in blue. Square root of x is h over 3. That is the equation number 4. What are we plugging in? We're plugging equation number 1, equation number 3, and equation number 4 into the integral. E to the h, dh is fine. 2/3 is fine, but square root of x ends up to be from 3 to 18. E to the h, 2/3, and then from equation number 4, here it is. You don't have to do it so messy. I like it, but h over 3 is square root of x. Maybe I will write down here. H over 3 is your square root of x. So I will have h over 3 dh. What do you think about this? Did you just blink and then you saw this and none of this makes sense? Let me know. It's very easy for me to explain again. Yeah?
So please explain again why you made an h over 3 square root of x.
Oh, the tea was hot. So we have e to the 3 square root of x. This was substituted by h, and we liked it. So it was amazing. E to the h cannot be better because we know how to integrate that. But then dx was not beautiful. When we solved for dx for this from the second equation, dx ended up having x in it. And that's not good. We're supposed to have integral with one variable until calculus 3. Then we're going to have several variables there. So we don't know yet how to integrate with different variables. Thus, I was thinking what to do with, let me put it in pink. I was thinking what to do with this part. I should change square root of x to something. And then I noticed equation number 1. Equation number 1 says h is 3 square root of x. So why not to solve for square root of x? So I did. Square root of x is h over 3. And I plugged it in. It ended up to be h over 3. Then when I substituted everything back to the integral, everything was in terms of h. And that was satisfying. Yeah? Well, thank you for asking. See, it's very nice to review everything. So that was the first part of all of this homework problem. Number 12. 6.1, number 12. That's your homework problem. So let me collect the constants outside of the integral. Highly recommend doing it all the time. 2 over 9. Pay attention to my calculations. I tend to make mistakes always on purpose. It's never a coincidence, but maybe you should double check. And then you have e to the h dh. That would be e to the u du if you choose u variable as a u substitution, which is not necessary. Anything you like, j dj, e to the j dj. And the limits of integration are changed. Did I mention that? That's important. In this case, let's do it. So now we have this integral. We still don't know how to solve it. This is a classical example for the exam. This part is integration by parts. Do you know why? This is perfect for integration by parts. Do you have any intuition why it is perfect for integration by parts? Yes?
Because you can just take h out and
Wait, he was answering. Yes. Oh, that's nice. That you're already choosing what to be u, right?
Yes.
Yeah, very good. We already know that u should be h because you differentiate goes away. It's amazing. Why do you think, though, it is integration by parts? Like, why it's different from the previous examples we had when we had u substitution? Yeah?
It undoes the product rule, so we can multiply.
Did you hear? If not, then someone should say here. Can you explain? Rephrase?
because it has product of two functions.
It's a product of two functions. It's a product rule. When doing product rule, two functions not related to each other, e to the h and h have no relationship when it comes to differentiation. So it's not a chain rule. Thus, it gives a hint that it is integration by parts and thus product rule of these two guys. Well, product of these two guys. IBP tells us, let's choose u to be something. And then we have this amazing hint of liate. Liate tells you you don't even have to hesitate. You see log, choose log, or inverse, choose inverse. Why? Because wherever you choose u, you can differentiate, while the whole other part will be integrated. You don't want to integrate hard functions. And log and arcsine, arctangent, arccosine, inverse functions are hard to integrate. They actually require their own integration by parts. If you see algebra, choose that to be u before exponential function. We see h and e to the h. Well, I will choose u to be h, just like you mentioned before. Because if I choose u to be h, derivative of h is 1. So it disappears, and we like that. Let's u to be h. This is my u. Does it confuse you with lots of letters? If it confuses you, it's good. We're supposed to train you to see more letters, especially if you are not pure mathematician. Pure mathematicians only see more letters later, but physics and engineers, which is physics basic, lots of physics, lots of engineering, they will see it a lot. Computer scientists too, you guys have lots of variables when you code. So they're supposed to be not intimidating at some point, but at first it's fine. Differentiate right away 1 dh. Then dv is not a choice. U is a choice, and we chose from liate or elate, and there was another version. dv is the leftover of whatever is standing. E to the h is a leftover. Integral of e to the h is e to the h. Spoiler alert, it's the same thing. E to the h gives you e to the h. Do you agree? That's integration by parts. That's 6.1. Yeah? dv. Oh, thank you for asking. So the formula of integration by parts says choose u first, and we made a choice. And then the leftover will be called dv. So the formula is integral of u dv. And that's why you only choose u, and then everything is a tail. I call it tail. U dv. And then the formula says the answer will be u. Let me show you, like color coded. The answer of this formula, or the next step of this choice, will be uv minus integral of v du. So it's part of the formula. Cross product gives me uv h e to the h minus, that's part of the formula, integral of bottom product of this table, v du, integral of v, well, v du is e to the h 1 dh. What do you think about that? That's the hardest part is done. After this, we're ready to answer. But this, I think, did you blink and now all of this doesn't make sense? So interestingly, that I personally would not do U substitution at the beginning. I was trained to just jump into integration by parts and hope for the best. And often it works. Often U substitution at the beginning makes extra hassle. You don't really need it all the time. But American students always do U substitution right away. It's completely different way of training, which is fine. It's just the way the brain works. Doesn't really matter. It's all important that you finish the problem. Some of it may be a more optimal way than another one, but it is what it is. So, e to the h dh, did you get where I got those two parts? Something is missing. Guess what is missing? We never did what before? Definite integral. Where is my 3 and 18? Did you just ditch them? No, they're still here. 3 and 18 bar 3 and 18. With a definite integral in integration by parts, you don't have to do anything special with those limits of integration. We only change them with U substitution. But with integration by parts, it's not a transformation. So you keep those variables and you just plug them in. Because remember, those were h, right? So everything looks okay. Because those were h, not x, not u, not v, then you can plug them in. Interestingly, integration by parts breaks the integral into two parts. The first part is ready, just plug your numbers. And the second part is hopefully an easier integral, and it is. It's just e to the h dh. So you have two ways of doing it now. Either plug the first part right away, or integrate the second part and then plug everything, because 3 and 18 will be everywhere. Let's plug into the first one right away. Plugging 18 everywhere is going to be 18 e to the 18 minus 3 everywhere, 3 e to the 3, and that is the first part. Top minus bottom, remember, plugging the top, plugging the bottom. Negative is inside, maybe I will color code like this. No, like this. Negative is inside of the integration part. Now it's going to be minus. This minus comes from the integration by parts formula. And I'm going to integrate e to the h dh. But that gives me e to the h. Duh. Bar from 3 to 18. So the second part is like one step delayed than the first part. And again, you plug in the top minus the bottom. So I have 18 e to the 18 minus 3 e to the 3 minus, don't forget, it's very important in this case to open parentheses because there'll be one more negative sign in the middle. So now it's kind of like too big. Minus parentheses, like so. And now I have e to the 18 and e minus e to the 3. Bless you. Like so, like so. The first part came from the integration by parts, the part that is ready. The second part was the easy integral, and we integrated it, and then plugged the numbers. And that is the answer. You can factor out e to the 18 if you want, blah, 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 e to the 3 if you want, but actually that's good enough. Yes?
What happened to the 2 over 9?
2 over 9. I hope I did not lose it. Ah, I did lose it. Did you notice the 2 over 9? It was on purpose. I made this mistake. Very good catch. I lost the 2 over 9. I was like, yeah, when you mentioned, I was like, oh shoot, there was some kind of constant. What happened to 2 over 9? We're supposed to multiply the whole answer by 2 over 9. Luckily, we know properties of the integral. If it was outside, just multiply the whole answer. But to make your notes correct, put a huge parenthesis in front of everything, 2 over 9. huge parentheses, maybe different color, 2 over 9. And finally here, 2 over 9. Thank you. Did anyone else notice? I see. Did anyone else notice? Okay, some people noticed. Good catch. Good catch. 2 over 9. Anything else is missing? Where is my plus c, for example? No plus c. It's a definite integral. The answer should be a number, and it is a number. Some kind of number. How many negative signs do we have? 3. Why? Top minus the bottom and top minus the bottom. Those are inside of the parentheses, and then the middle negative sign comes from the formula of integration by parts. Look at this very beautiful short example. This example required u substitution and integration by parts, and don't forget the constant and so on. So it's a pretty long example. What do you think about this? Ask me before we move on to the next chapter. Questions, ideas, suggestions, comments? Yes? Too long. So usually we give you classical one. Sine times x, or e times x squared. Actually, no, that's a bad one. E times x, and so on. Not very classical. So luckily, before the exam, I will be showing you that we have exam reviews, and we just take problems from there. We gave you like 46 problems to practice, and then it's very easy to copy it from there, change 3 into the 7, and it's new example. So yeah, the first exam usually have so much integration that it doesn't make sense to make it harder. Just figure out integration. I'll be talking about it later. It's too early. That's a good question. More questions? Homework is called homework because at home you have more time to work on it. That's why it's a common notice from students why homework is so hard to make you suffer. But then why exam is not so hard? Because it's 50 minutes long, okay? It's already suffering because of the stress anyways. Yes?
Yeah, so we leave the answer over there itself, right?
I can do like, I would leave like this, but it's a good question. To be honest, we could simplify. 218 over 9 is 2 times 2, right? So it's going to be 4 e to the 18 minus e to the 18. Could actually factor that out. Oh, not I have to factor it. We can just combine it. Oh wait, 2 over 9 is everywhere. So it's 18 minus 1. That's 17, right? 17 times 2, it is 20. 17 times 2 is 34 over 9. Minus, okay, in that one I have to kind of think harder. Minus 3, just a second. Plus 1, that's minus 2, right? Huh?
4 by 9.
Yeah, but I'm going slowly. Minus 2 times, minus gives you plus. Plus 2 times 2 is 4 over 9 e to the 3. Oh yeah, much better. Should have done that. Good. Looks better. Looks more satisfying. What do you think about this? Very good. Let's move on to the next chapter. Now you know everything you need to know about integration by parts. Your job is to keep struggling with your homework. Not more, not less. But luckily, the forum is very active. We are already answering lots of questions in the forum. Number 12, number 4. 5.5 has lots of questions solved, so definitely take advantage of the forum. Besides, I give extra credit to top 20. It's very easy to be top 20. I actually overdid it this time. It's supposed to be top 15, but when I post something, I don't like changing it, so it's too late. You basically like